Hello everyone, welcome to the Data Bytes and Consultancy. Today we will discuss the case study of Refresh Company. So Refresh Company is a beverage company and it is facing new challenge. Even though the Refresh Company is investing on advertising, their sales had reached a particular level and now the sales are not growing. Saira is the CEO of the Refresh Company. Saira turned to Data Bytes for an innovative data-driven approach for effective marketing and growth. Let's look at the challenge. Saira was particularly concerned about their TV advertising efforts. She believed that TV ads played a crucial role in driving sales but lacked the necessary data to substantiate this belief. To address this issue, Saira engaged Data Bytes to analyze the impact of their advertising budget, specifically focusing on the relationship between television advertising and sales performance. So here we are using the dataset from Kaggle. The link is given over here. Let's look at our data. So our dataset contains 4 columns: TV, radio, newspaper and sales. So you can see over here, TV column represents the amount spent on the TV marketing, radio column represents the amount spent on the radio marketing, newspaper column indicates the amount spent on the newspaper marketing, and this is the sales column. Let's move to the data understanding part. First we will import the warnings and all important libraries. In the next step we will import the data. Now let's look at the head of the data. Now we will look at the shape of the data. So there are 200 rows and 4 columns in the data. Let's look at the columns of the data. As you already know, our data set has 4 columns: TV, radio, newspaper and sales. Let's look at the data types of each column in the data. So the data type of all columns in the data is float 64. Now let's look at the null values in the data. So there are no null values in the data. Let's look at the info of the data. So .info indicates that the data type of each column and non-null values. Now let's look at the statistical summary of the data. So statistical summary is shown for the numeric columns only. The money spent on the TV marketing is significantly higher as compared to the money spent on the radio marketing and newspaper marketing. And we can also see that the minimum value for the radio is 0. Now let's look at the number of records for which the value of radio is 0. We can see that there is only one record. Since there is only one record with 0 value, we can safely ignore it and we don't need to pre-process this further. Let's look at the duplicated values in the data. So as we can see that there are no duplicated values in the data. So till now we understood the data. What is the structure of the data, how many columns are there, what is the data types of each column in the data. Now we will move on to the data visualization part. First we will plot a scatter plot for each variable across cells. So you can see that blue color represents the scatter plot of TV and cells, orange color represents the scatter plot of radio and cells, and green color represents the scatter plot of newspaper and cells. So from the above scatter plot we can clearly see that the TV and cells are linearly correlated. So the first assumption of the simple linear regression is validated, and there is a positive correlation between the TV marketing and sales, which simply means that if we spend more money on TV marketing, the sales will sales will grow. Now let's look at the distribution plot of all variables against sales. So from the distribution plot, we can see the distribution. The distribution of newspaper variable is left skewed. We can also see the histogram in the distribution plot. Histogram basically indicates the frequency. Now we will visualize the box plot for TV, radio and newspaper. From the box plot, it is evident that there are outliers in the newspaper. But since we are interested in the TV variable, we are not going to treat outliers in the newspaper variable as of now. Let's look at the correlations. So we can see correlations using .CORR method. The correlation between TV and sales is 0.90. It indicates that the TV and sales are highly correlated. Now let's plot these correlations using heat map. We have used the blue color shade for the heat map. The light blue color indicates the lower correlation, whereas dark blue color indicates the higher correlation. Now we are done with our data visualization part. Now we will move on to the model building part. Since the data meets most of the necessary conditions for linear regression, we can proceed with the model building. So in the model building process, we can start by defining x and y. So x is the independent variable and y is the dependent variable. So in our case, TV is our x and sales is our y. In the next step, we split the data for training in the training dataset and test dataset, and we are defining the test size at 0.2. Means 20% data will be test data and 80% data will be training data. In the next step, we will build the model. Now we will make predictions on the model. Once we make prediction, we can check the parameters of the model, like the intercept and the coefficient of the model. It turns out that the equation of the line which we fitted in the data is y equal to 7.01 and 0.06 into TV, which means that if no budget is allocated to TV ads, sales are 7.01 units, and for each unit increase in the TV budget, sales increases by 0.06 units. Now let's evaluate the model. So as of now, we are using only two metrics to evaluate the model. One is R squared and another one is mean squared error. So the R squared for the training dataset is 0.81 and R squared for the test dataset is 0.8. So R squared indicates the variance in the model, and the mean squared error for the training dataset is 5.0 and the mean squared error for the test dataset is 6.1. Now let's visualize the model that we have built on the data. We can see that blue points are the training dataset and orange points are the test dataset, and this green line is our model that we have just built. In the next step, we will do the residual analysis. So you might think, what is residual? So residuals are basically error terms. It is the difference between the actual y value and predicted y value. First we will calculate the residual. Then we will plot those residuals. We will plot the distribution plot. So this distribution plot is not available in the latest version of the Seaborn. We can see the bell-shaped curve for the distribution of error terms. It shows that the error terms are normally distributed. So the second assumption of the simple linear regression is validated. Now let's plot the scatter plot of the residuals. From the scatter plot of residuals, it is clear that the error terms are independent of each other. This validates the third assumption of the simple linear regression. The variance of the error terms is not changing. It means that the error terms have constant variance, and this validates the fourth assumption of the simple linear regression. Now let's look at the recommendations. So based on our comprehensive analysis, Databytes recommended RefreshCo to increase its television advertising budget. We provided Syra with substantial data to support this recommendation, demonstrating a clear relationship between money spent on TV marketing and sales growth. Let's look at the conclusion. With data-driven insights in hand, Syra and her team felt empowered to adjust their advertising strategy. Following the implementation of your recommendations, Refresh Company experienced a significant uptick in sales over the following months. The partnership with Databytes flourished, leading to further successful collaborations in the competitive beverage market. So here we comes to the end of this video. In the next video, we will look at the multiple linear regression. So stay tuned and subscribe to the channel.